Okay. Let's see what we have here. Okay. I figured I'd do a little bit of discussion on cosmology. I have the title Cosmology in Crisis. More of an attention grabber, not of creationist stuff, but more of skeptics. But anyway, I wanted to talk a little bit about this cosmology, sciences, and everything. So what I think I'll do here, let me see if I have to share first, and then add to the stream, and we're off. Okay. So the recent James Webb telescope has brought some interesting things to light. The first thing you notice with this image here is the extreme gravitational lensing effect of these galaxies in the background. Now the mass is here, located here. The lensing is around the outer edges here. In many cases, well, this one is probably from a mass here. This is from a mass here. But in general, it's a lot of concentration of mass in this area, causing a lot of extreme gravitational lensing, which brings these red-shifted galaxies up front so that we can see them, because otherwise they'd be very difficult to see. So besides stretching out the galaxies, this extreme magnification is also bringing to the forefront some of these galaxies off in the distance, which are extremely redshifted. And the surprise to many of scientists, which wasn't a surprise to creationists because we predicted it, is how fully formed these distant galaxies are. All these red ones, all these red galaxies here are extremely redshifted because of their distance. And you probably couldn't even see it with a regular telescope. Probably couldn't even see the galaxies because of how redshifted they are. They're into the infrared spectrum, which is what the James Webb telescope is using, infrared light. And this data is actual data. So if you look at this spiral armed galaxy here, it's not an actual image, but it's actual data that's translated into visible light for us to see in our wavelengths that we're able to see. Because otherwise, you probably wouldn't be able to see these galaxies. Well, especially the redshifted ones. The redshifted ones are like way, way beyond it. So the question is, in my mind, this is because the light is traveling such a distance, is that the wavelength of the light arriving to us is extremely, or redshifted, so that it actually changes wavelength by the time it sees us, or by the time we see it. So this, from this spectrum, the redshift, they determine that the space is expanding, but they forget one minor detail about the expansion of space causing the redshift, is that that not all of space is expanded. Only outer space in between us. For example, this is what I try to point out to people, I mean, the scientists, which they have a hard time seeing, is that it's the distance. There's nothing in between this red galaxy in our eyes or our detectors, our James Webb detector. There is nothing between there and here. So you're talking about extreme distances with no matter, because the more matter there is, for example, here, it slows down time. And in slowing down time is what causes the lens effect, because light takes longer to pass by this area here than it does this area over here. So light travels faster over here than it does in the center of the mass, which causes a lens effect. It's the exact same thing as a lens, a glass lens that we use. The thicker part of the lens, the light travels slower. The thinner part of the lens, the light travels through faster, obviously, because it's not slowed down as much as the thicker part. It's the exact same thing as a glass lens, only with distortions. Because, of course, it's not a perfect lens here. But it's the exact same thing. The light passing through this area is slower than the light passing through this area around here, which causes the lens effect, or out here, which causes the gravitational lensing effect, which effectively magnifies these redshifted galaxies far off in the distance behind this galaxy, this mass here. So if that's the case, then we know that the light between this red galaxy, this red shifted galaxy here, we know that it's a very long, far distance, and not only is it a far distance, but we know the light is traveling faster where there is less mass than where there is more mass, which is not even taken into consideration by the scientists when they calculate distances and times and everything and ages, is that the light traveling to us over here, because of the distance with no matter between our eyes and the galaxy, there's nothing to slow down the time. There's nothing between our eyes or our detectors and this galaxy, the redshifted galaxy. There's nothing to slow down time, with the exception of course, this mass over here. But the point being is that there's a difference in the rate of time. Light arrives faster here than it does over here where there's a lot of mass. That's just a fact. But they're not taking into consideration the fact that in outer space, between us and the distant galaxies, there's no matter to slow down time. So that there's basically nothing to slow down the rate of time between us and our galaxy. Of course, when it enters our galaxy, when this light enters our galaxy, then time starts to slow down a little bit, or slow down some. But of course, it's still the speed of light. But with nothing between our eyes and this galaxy, there's basically nothing to slow it down until you get into our galaxy, which is where we are, which is at the speed of light, 186,000 miles per second. But there's this thing about billions and billions of years. So what? So what if it's billions of years? The time is going by faster. The billions of years is going by faster from when the light was emitted to when the time reaches our eyes is a matter of probably just thousands of years, which allows for a 6,000-year creation. But a lot of people, I know they're not thinking about it because they never talk about it. But not even creationists are talking about it either, for that matter. Just like a lot of creationists aren't talking about the out of Africa markers, the markers that show an out of Africa descendancy, which is exactly backwards. But I don't hear any creationists talk about it, trying to refute it, or or else they would have to face the fact that either there's a connection there going out of Africa, or it's the exact opposite going the other way from Eurasians. But nobody's there yet. Anyway, here we go. No comments yet, so that's not too bad. I guess no comments is good news. But this is one of the discussions that I have with the secular scientists is that they're not seeing the actual age of the universe as it is, because the rate of time is never the same everywhere in the universe. The rate of time is always changing, and the measure of distance is changing too. So between here and in a distant galaxy or any galaxy, the measure of distance is increasing, not increasing, increased or expanded, not expanding, but expanded between us and the next galaxy. Not that the universe is expanding, it's just expanded distance. And the farther away the galaxy is, the more the distance between us is expanded. So they're thinking, oh, well, that means a galaxy twice as far is expanded twice as much. Yeah, of course it is, because the distance is expanded to begin with. But it doesn't mean the universe is expanding infinitely, because that's nonsensical. It's nonsensical and that's that's what they base their whole Big Bang on is the redshift. The redshift of the expanded distance between us and distant galaxies. So this expanded distance and the redshift, they're saying, well, that means the universe is expanding. Not necessarily. It's just the distance between the galaxies is expanded, and the universe is not expanding. It's just, you can think it is expanding, but it's only the distance between us and the distant galaxies that's expanded, not that the universe is expanding. But that's what they base their whole belief on, is that everything, the entire universe used to be in a single point, like a single speck, or basketball, or baseball, or golf ball, or speck, or dot, or you keep changing it, but that's what they believe. Which doesn't make a whole lot of sense anyway, but that's what they believe happened. That's their creation model, their creation myth. It's the Big Bang. That's what I could have to make a title, the creation myth of the Big Bang. Big Bang, the creation myth. Anyway, But the reality is more that um, instead of the universe expanding or inflating, they're looking for a quote unquote inflaton, but which is another, you know, wild goose chase, you might say. But instead of looking at the universe like as inflating, we need to understand that it's the creation of matter with mass that dilates time and distance. If you don't have any matter or mass, you don't have any dilation of distance. Of course, if this galaxy was an actual size, the actual size of the galaxy, it would be huge. But of course, it's probably gravitationally lensed. It looks like it's lensed, so it's magnified. It's actually magnified, so it's bigger than what it actually is, or would be if there was no magnification, of course, makes sense. Because some of these others are smaller. These white ones, there's a lot of white ones that are smaller than this red one is huge, but it's huge because it's being magnified, being brought up from the distant background, so that we can see it. That's what a magnification is, of course. But it's the creation of matter that has mass. Of course, hydrogen has mass, but if you have the heavier elements, and if you have, of course, black holes would have a kind of matter that's extremely dense with a lot of mass. So inside of each of these galaxies is one or more black holes that are extremely massive. And that's what dilates time and distance from distance being infinite and from time being instantaneous. It slows down time so that things can take place within a dilated distance or quantifiable, measurable, limited amount of distance and slow down time, or in time that's slowed down. So things take time to occur. And that's what allows for our physical existence. In biology, is that things take time to occur because we have all kinds of mechanisms and machinery and batteries and electrical charges and everything that has to take place in time and space. And that's only possible is if you have dilated time and distance. Of course, if you didn't have any dilated time and distance, of course, we couldn't exist. So we're a fabrication. The whole universe is a fabrication based on these, what I like to call tent poles, which stretches out the universe, or actually contracts it. It binds and contracts time and distance in each of these galaxies. Each of these galaxies contracts time and distance. Of course, if you get away from them, then there's no matter to contract or dilate time and distance. So that means that light travels faster between us and this galaxy where there's no mass to slow down light, the light reaching us, or to slow down time, which accelerates the speed at which light reaches us, which is the reason why we can even see these stars in a 6,000 year universe, because billions of years pass by at the same time as thousands of years pass by where we are, which is probably the reason we can see the galaxies in the first place. But anyways, this was a surprise to a lot of scientists, but not creation scientists, because that was our prediction, that there would be fully formed spiral galaxies way off in the distance, which, according to their model, their Big Bang model, they weren't fully formed yet. As a matter of fact, they have a scale somewhere where they were trying to show it. See if I can find it. And if you want to know the difference between James Webb Telescope and Hubble, the Hubble has 4-pointed stars, whereas the James Webb Telescope has 6-pointed stars, which is right here. No, that's a 4-pointed star. Let's see, 4-pointed. That's 4-pointed. Here's 6-pointed. This is what we call 6-pointed star. This is James Webb Telescope image because of those hexagonal mirrors. That's 6-pointed. So that's James Webb. That's how you can tell the difference, in case you wanted to know. You can look at any of these pictures, and if there's a star, a bright star in the picture, then that's how you can tell which is which. There's again, there's 6-pointed James Webb stars, and of course, very distant red-shifted galaxies in the background. So now there's one. This is the one. Yeah, this is the one I want to look at. This is the Big Bang prediction, the age of the universe in billions of years. Okay, it's 13.7 billions. Okay. Now, see, notice how, because this was made before. This was made before the James Webb Telescope, of course, because their prediction, well, they have the JWST here, but this is what I want to point out is that notice the spiral galaxies here. You have them here, here, and of course this is time, right? This is the age. This is time. Oh, here we go. So you have spiral galaxies, fully formed galaxies here, 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 but not here. Not here, not here, not here. Okay, this is the first galaxies, and this is how far the Hubble telescope Chandra Deep Field can see. HST, the Hubble, can see back this far in time where there's still galaxies, right? First galaxies are formed in this time. And all of a sudden, you have the first stars. First stars are formed here, and then galaxies. But the problem is, as far as the James Webb Telescope, can see, this is JWST, right? So as far back as it can see, we know now there's fully formed galaxies all the way back here, according in time, just before the first stars were made, because of course we can't see stars, but we can see galaxies. So I think it's funny that just before the galaxies were formed, the stars are formed, right? Because this is supposedly Big Bang. This is supposedly cosmic microwave background, the CMB. The CMB, cosmic microwave background, is right here. That's what the static is supposed to mean. Of course, it's not all static because there's a lot of static from everything else too. But probably this static is from something else too. But this This is what they call the dark age, when nothing was being illuminated, nothing was shining. Then when the first stars started to shine, then they coalesced into galaxies and formed the first galaxies, according to the Big Bang model, right? So you have this expansion of plasma, or extremely, extremely, extremely hot. You can't, so hot you can't even understand how hot it is. But because if it expanded today's universe, it's cooled down quite a bit. But of course, they have the first stars forming, then the galaxies, but they didn't expect to see fully formed galaxies here as far back as the James Webb telescope could see. And it turns out that all the way back, the beginning, 0.3 or whatever, 100,000 years. Okay, this is billions of years. I guess this is 1 billion. So 0.3, from 0.3 to 1 billion years of the existence of the galaxy, after the Big Bang. After a billion years, you're supposed to be able to see galaxies, but they didn't expect them to be fully formed, spiral-armed galaxies, what we see today. Which begs another question: why are they spiral-armed if it's billions of years old? Which never made sense to begin with, right? The universe is 13.7 years, but you have to understand that time inside the galaxy is not the same as time between the galaxies. Time between the galaxies is running at a much faster rate than time inside of the galaxies. How do I know? Well, because of the evidence that we see of, let me see, of the spiral arms themselves. Because the spiral arms themselves are moving. They're moving around the galaxy at a faster rate than what is predicted by the Big Bang, or by the known matter in the universe, or in this area, this vicinity. But what they don't take into account is that the time is going by faster out here than it is in here. Time is going slower in here. That's why things are moving slower, because time itself is slower. But we can see across vast distances of space, and from the inside of the galaxy to the outside of the galaxy is a vast distance. Of course, again, this is not actual data. I mean, it's not an actual picture, but it's actual data that they make the picture out of. So this isn't an actual image of the galaxy, even though it's not an actual picture, technically, but it's actual data of the galaxy. It might not be actually this wide or whatever, but it's actual data. But they have always wondered why these spiral arms are moving so fast out here compared to how fast the galaxy is moving inside near the center. But they forget these are great distances from the center where the mass is. The greater mass is in the center. The farther you get away from this mass in the center, the faster time goes by. So that means time is going by faster, which effectively, it effectively changes the speed of light as we see things over large distances. In the center, things are moving, but actually time itself is going slow. The clock is going slower in the center than it is on the outside. The clock is going faster on the outside than it is in the center. I mean, it's that simple. But then that's one evidence of the accelerated rate of time within the galaxy itself. So if within the galaxy itself, the time is so accelerated as to make the arms move faster out here than they are in here, as expected, not that they're going faster, they're just going faster than expected. If it affects the rate of time that much from the inside of the galaxy to the outside of the galaxy, then what about between this galaxy and our detectors, our eyes? What about that space? What about that distance? That's the distance that is extremely expanded, and time is running at even a faster rate than it is out here in this outer spiral arms that's close to the center of the galaxy. Relatively close compared to the distance between our eyes and the galaxy. Okay, another thing is so another evidence, another proof that time is moving faster the farther away you go from the galaxy is, did I pass it up? Or did I miss it? I'm going to have to do it individually. I'm going to have to go here. I'm going to have to go here and find it. Where'd it go? Oh, right here. I have to make an individual thing here. It's a different kind of a picture, I guess. It has to be a web image of some kind. Okay, so I'll just go ahead and wait for that to open up, and this, take forever. But anyways, meantime, let me see what we got going on here. We got some people commenting here, I guess. If I can move this away, I don't know. No. My computer is going slow somehow. Windows just updated or something, and it's like taking forever to do stuff. It's not even surprised that this thing is even working at all, but whenever I do something like that, oh, there it went. See? Oh, my dropout. Oh, we got my dropout. How you doing? There we go. Let's see what my dropout says. Hello, Doki. Doki. Hey, John. Oh, get John. Jay. Okay. So, yeah. Pretty cool pics. From the James Webb. Yeah. No nebula formation would precede the star and galaxy development. Okay, time beams environment. Anyways, your Big Bang predictions, even entirely wrong, doesn't get you to God. Well, it does eventually, but you just have to follow the evidence where it leads all the way. But anyways, still waiting for this picture to come up. Probably come up in a little bit. Something really wrong. Okay. Formed over millennia. Well, as far back as the James Webb telescope can see, there's fully formed galaxies, which was totally not expected by the Big Bang predictions. Well, this thing is, I don't know what's wrong with my computer here. It's really messing me up. Trying to update or something. I don't know what it's trying to do. But it's really slow in getting it to work. It'll probably make it worse. That's not even working. Not even. Hello, Sandy. How are you doing? Trying to get my computer, waiting for my computer to work, but it's Anyway, there we go. Now if it'll open, I'll just try it again. I can put that down. That's working now. Sort of. Formed over millennia. Okay, so down here, there's supposed to be an icon appearing down here. Bad weather, maybe? Well, I think it's more my computer. It's little Keith Coben. But in the meantime, we can maybe talk about John's statement here. Anyways, your Big Bang predictions, even if entirely wrong, doesn't get you to God. Well, it's not an interesting comment. Let's see. Time is variable already being accounted for because expansion rates are accelerating. Let me check this out first. Time being variable is already being accounted for because expansion rates are accelerating, not constant or slowing down. Well, it seems to me that they appear to be accelerating because the galaxy twice as far has a showing redshift twice as much, but that's because the distance is twice as far, and in between, because you're showing redshift right on a galaxy so far twice as far as showing twice as much redshift. Of course, it's showing twice as much redshift because it's twice as far as the first galaxy, which has expanded distance from us to it. So of course, the redshift is going to be twice as much on one twice as far. Duh, you know. But anyway. Okay, let's see. Are you familiar with plasma astronomy? Well, that's what I wanted to get to. I wanted to show this plasma uh, jet shooting out of a galaxy, but my computer's not cooperating very well. Oh, here it is, right here. Anyway, restore. I don't want to restore that. Okay, here's a plasma jet. Now this thing here, that's not working. I would go like this. This thing here. Oh, there we go. Let's try it this way. Okay. This is the center of a galaxy here. And they had a plasma jet shoot out from this galaxy. They observed it, and I don't want to say real time, but they observed it as it was happening. They observed this event as it was happening. So in other words, this center of this galaxy was like, looked just like this white blob or whatever, or maybe not as much. But then this jet of plasma shot out from this galaxy, from the center of the galaxy, and they measured the distance from here to here, and they said it shot out 6 or 7 times the speed of light. First, I thought it was 5 times, but it turned out it's more like 6 or 7 times the speed of light, according to their calculations. So then they try to backtrack and say, oh, it was pushing out space with it. And then they try to do calculation, some kind of a pi calculation, saying that it only appears to be going out faster than the speed of light. Well, the most you could get, even if this jet was lined straight at us, the most you could get is twice the speed of light, because they're saying that it was the speed with which it shot out plus the speed of light, which was twice the speed of light. But wait a minute, their observation was 7 times the speed of light, not twice the speed of light. The most you could get is twice the speed of light, even if it was shining straight at us or coming straight at us. But it's because it can be explained if you understand that the distance, the farther away you get away from the center of this galaxy, the more distance is expanded. And you can actually see it here, that this is actually wider than it is back here. So the farther away you get from the galaxy, the more expanded distance is. Not only that, the farther away you get from the center of the galaxy, the faster time goes by. So the rate of time here is not the rate of time here, nor here, nor here, nor here. The more this shoots out, the faster time passes by. And so the faster the events take place. Plus the fact that it's an expanded distance from here to here is an expanded distance. I mean, it's more expanded here than it is back here or back here. The distance itself is expanded the more you get away from the center of the galaxy. That's how you explain this jet shooting out 7 times the speed of light, because your calculations are wrong about the distance and the measure of time. Because the speed of light changes, not that the speed of light changes, but over great distances, the measure that how you measure the speed of light changes. The rate of time goes faster and the measure of distance is greater. And they aren't even considering it. I know they're not, because they don't talk about it. Because if they were considering it, they would be talking about it. But nobody's talking about it. But anyways, there's that. So I guess I got that. Anyways, oops, I forgot. Forgot to take this off here. I'll have to find it. Anyway, okay. So back here. Scientists and labs have created galaxies using plasma tech. All the galaxies. There was a conference in Australia. Put this up. The Boomerang Conference. In that cosmic microwave background, or whatever it's called, they have detected music. Oh, music. Well, what kind of music? Well, I think I heard music coming from galaxies. I heard something about that, but I don't think it was actual music. Music working on plasma. If you could give me a temporary wrench, I could post a link. Yeah, I'd have to go. I have to go on my phone. I could do it. But let me just see. Okay. Let me, because I'm trying to give people wrenches anyway. So I'll just go ahead and get my phone here. See what I got here. Okay. I'll go to mine. Okay, I've got to turn down the volumes. Okay, here we go. Okay, add moderator. There it goes. Keith Kubin. He already got moderator. Let's see. Okay. Anyway. All right. I'm um, I'm live streaming from the what do you call it? I'm using the phone to live stream. It's and then Wi-Fi to my computer. I heard something about, but that's music from a fabricated. It's music from a fabricated galaxy or something. I thought I heard something about music from a galaxy, but I'm working on plasma. Okay. All right. Okay. There's the there's the link. All right. Right there. There's the link. I'll have to check it out. Oh, okay. Yep. All right. So, that's good. Yeah, we can check it out. I'll have to check it out. I have to do it when I finish the live stream, I guess. Unless I don't know if I can't do it from here. Yes. No. I have to do it from my phone, which I just closed out the browser. Audio is very good. Okay. All right. Okay. So, well, anyway, that's some of the things that some of the problems that the Big Bang has. Um, oh, here, where to go? Okay. Some of the problems that the Big Bang has is that um, well, it's kind of ridiculous to begin with, but they're counting on this redshift, this expanding universe, to say if it's expanding that much now, it was expanding so much in the past, and some 13 billion years ago, it was one basketball or one softball or one golf ball or one period or something, one dot. But if you understand that it's the formation of matter or the creation of matter that dilates time and distance, then you'll understand that the time is going slower where this mass is, and time is going by faster out here. Same with distance. Distance is smaller near the center, and you can actually see how much smaller the distance is here compared to out here. The distance is greater out here than it is here. But of course, they could claim that it's being spread out, but it's more. But it's still expanding. The distance is still expanded out here more than it is back here and back here. If you understood that, then you would understand it's the formation of matter that dilates time and distance. So it's all this matter that dilates time and distance. But if you get away from a galaxy, if you move away from a galaxy, there's no matter to dilate time and distance. So this is Einstein ring. I think this is a James Webb picture, even though you can't tell. But we can actually observe that time is moving slower here than it is out here because it's causing a lens effect. It's called gravitational lensing. So we know there's different rates of time. So the light reaches us faster from out here than it does from in here. That's what causes the lens effect. And that's what brings these distant galaxies into view. From way back at the creation, they were surprised to see a fully formed galaxy like this, fully formed at a time when there's only supposed to be stars and no fully formed galaxies yet, because that's how far back the James Webb telescope is supposed to be able to see. And they were surprised to see that there's fully formed spiral galaxies as far back as you can see. They were surprised because they're not realizing that time goes faster between when the light is emitted from the galaxy to the time that it reaches us. Time speeds up. So when the Bible says a day is like 1,000 years, 1,000 years is like a day, you could actually literally say a day is 1,000 years at the same time as 1,000 years is a day. And you would be correct. And people say there's no science in the Bible. There's no science in the Bible. Well, seems very scientific to me. Here's a I don't know what they call it, a spiral galaxy. I guess it's a spiral galaxy, but it's extremely warped because of the gravitational lensing of this galaxy here. So the mass of this galaxy here is bringing the light from this galaxy here up in the view. It's not actually this big. This redder or more orange galaxy is not as big as this one. Of course, it's not real far back in the distance because of its size, because it's huge. It looks almost bigger than this, but it's not actually bigger than this. It's just a lensing, gravitational lensing effect and a stretching effect from the warped lens. That's not a perfect lens, but it does prove that time is going by slower here than it is out here and out here and out here. So when you get away from large masses and you're looking straight at a galaxy somewhere, here's a spiral galaxy, redshifted. You're looking, there's nothing to slow down time from when the light is emitted from the galaxy to the time when it reaches our detectors in our eyes. There's nothing to slow down the time. So time goes by faster. Billions of years go by while the light is traveling from this galaxy to us, because time is going at a faster rate. Because it's proved, because when you got the plasma jets coming out from the center of a galaxy and they're saying it's going 7 times the speed of light. Well, what about beyond that distance? The distance between us and the galaxy is so much greater than that distance. Sure, that's a great distance, and you can see the effect of that distance. But what about the distance between us and the farthest galaxy that we're seeing? And of course, a more distant galaxy, double the distance, is twice as redshifted. Of course it is, because it's redshifted for the first one we see, and it's double for the second one because it's twice as far. Of course. I mean, that's common sense. I mean, that's obvious, right? But it doesn't mean the universe is expanding. If you understand the effects of general relativity, the universe is not expanding. The space between us and distant galaxies is expanded, not expanding, because an expanding universe is nonsensical. So you don't need dark energy. You don't need dark matter to explain the spiral arms of the galaxy going around faster than expected. You don't need dark matter. You don't need dark energy when you understand general relativity. You have to do the thought experiments of general relativity, just obvious understanding that you have different rates of time going on in different places. Because that's what gravitational lens is. It's a time is going by, the light is arriving faster out here than it is around here. That's what causes the lens effect. It's the exact same thing as a glass lens that slows down light. Light is going down, slow down here, going slower here than it is over here. It's the exact same thing. That's what gravitational lensing is. Okay, this is James Webb. Here's a James Webb. Okay. Fully formed galaxies. Okay, this is interesting. 50 arc 6. Okay, so we have highlighted here 7A, 7B, and 7C. So 7A is down here. Here's 7A. And here's 7B. And up here somewhere up here, there's 7C. Now this is all the same galaxy. They can look at these galaxies, and if it's got an identical radio signature, identical chemical signature, and everything, they can determine that it's the same galaxy that's being seen in all these places. So the 7C, the 7B, and the 7A are all the same galaxy. But they're just showing up in different places because of this extreme gravitational lensing. Now, this lensing effect is looking at the farthest most galaxies that exist. Okay, so this picture of 7A is distorted, right? It's somewhat distorted. Oh, here we go. 7A is distorted, 7B is distorted, but 7C is the same galaxies, same three galaxies here. And 7C is not as distorted, so if we can zoom in, we can see they're fully formed galaxies. Now, these galaxies are extremely far away. Now, this image here is not as distorted as the other images are distorted, but it's the same galaxies. But look how fully formed they are. This one here is almost like a spiral galaxy. It's basically a spiral galaxy, but it's fully formed. You can't tell how spiral. This looks like spiral too, right? Looks like a spiral galaxy. They look like spiral galaxies, but the fact is that they're fully formed galaxies, and they're the farthest galaxies that James Webb can see with the help of gravitational lensing. In other words, they're magnified. These galaxies are magnified by the gravitational lensing of this mass, this mass area here. So we know that time is running at different rates. We know distance has different measures. So the farther away you get from a center of mass, farther away you get from the center of mass, the more distance is increased. So instead of the plasma jet shooting out 7 times the speed of light, which we know is not possible, it's the rate of distance, or the measure of distance, that is increasing, and the rate of time is also going faster. The farther you get away from the center of galaxy, the more the faster the rate of time goes, and the greater the measure of distance is. In other words, distance expands the farther away you get out. Not that it's expanding, but it's expanded. Distance is expanded the farther away you get from the galaxy. That's why the observation is that it's going 7 times the speed of light, because their measure of distance is wrong. Because it's not the same distance here as it is here. Like this distance here could be the same as this tiny little speck here, distance here. Could be the same distance. The distance is expanded. Not only that, is the rate of time is going by faster. So the same way the spiral arms go around faster than expected, this plasma jet's going to go shoot out faster than expected the more it comes out here. And they could use this to determine how much expansion there is in space. And if there's that much expansion within a galaxy, which is the galaxies over here, but I guess this is all part of the galaxy. But if there's that much difference in the expansion of distance and the increased rate of time within a galaxy, what about the distance between us and this galaxy? It's got to be even more expanded, and the time is running much faster than it is near the galaxy. But anyways, no, I know nobody's considering it because nobody's talking about it. But I guess that's good. That's good enough for today, I guess, God stretched out to heaven. Yes, exactly. The distance is stretched out the farther away you get from the galaxy. So we're at the center of the universe. It's possibility. We don't know how much universe God made, for that matter. Time increases and distance expands. Yeah, the farther we get away from the galaxy. Hello, Brother Timothy. Okay. So, but that's one of the things there that I try to explain to scientists, but they don't seem to realize or understand that, what's causing the plasma jet to shoot out 7 times the speed of light. And they're trying to backtrack and explain it with some kind of crazy math or something, but the most you could possibly get is twice the speed of light, even if the plasma jet's pointed straight at us, which it's not anyways. But if you understand the distance is expanded or stretched, then you'll understand that, why it appears to be going out 7 times the speed of light, because the measure of distances you're using is wrong, or the scientists are using is wrong. I wonder why they've been so quiet. They were so excited when it launched. Oh yeah. Yeah, they are a little bit quiet, but we predicted it. We expected to see, and I was thinking like, wow, I hope they find spiral galaxies all the way back as far as you can see. Hope they find fully formed galaxies as far back as you can see, because that's a prediction of creation. But that's what they found, verifying creation, and yeah, they kind of like went quiet. But which always happens, with the genome, they kind of went quiet, and then they try to explain it. They'll be back. They'll be back with trying to explain it away or change. They'll change their science. They'll change their predictions. Uh, Now we're excited that they launched it. Yeah. I was expecting them to see the results that I saw, and it's just amazing. The extreme gravitational lensing is so amazing. It's like it's just so awesome. I mean, that's you're talking about extreme dilation of time and distance. Extreme, which is what I expected to see, but it's just so awesome to actually see it, because this is a six-pointed star. The six-pointed star is a James Webb telescope from the hexagonal mirrors. There's 6 points. The Hubble is only four-pointed. The James Webb is six-pointed stars. So it's just extreme. It's exciting to see, and especially to see this far back in space, especially to be able to see this far back in, what they would say back in time, which is not so far. Maybe it's 6,000 years ago. 6,000 years ago, we're seeing back 6,000 years, and there they are, fully formed galaxies going back 6,000 years, just as we expected. And these are as far as James Webb can possibly see, and they're actually fully formed and spiral. They're actually spiral. You can actually see spirals here, but which is, we're wondering why you can see spiral galaxies today. If the universe really is 13 some billion years old, how is it we got spiral arm galaxies in the first place? But they're fully formed galaxies, to be sure, which is totally unexpected, because when you go back in time, you're only supposed to see stars. You're not supposed to see fully formed galaxies, which they didn't expect to see. The James Webb telescope, James Webb sees all the way back to the beginning, 13, well, maybe 12 billion years or whatever. There's only supposed to be stars here, first stars, which you can't even see, but we're seeing fully formed galaxies all the way back, which is supposed to be the beginning of the universe. Back here's the cosmic microwave background, and we're supposed to be seeing, should be like a blob. I guess they expected to see like a red blob or something. I mean, a red, something like the cosmic microwave background. But they never expected to see fully formed galaxies, because the first galaxies formed in this time, but they didn't expect them to be as big or as fully formed as they have been proven to be. But it's funny, they got the James Webb going as far back as almost the first stars, but it's actually seen the first galaxies, which are 6,000 years old, fully formed, just as we predicted. So I'll give them this age of the universe as far as between I mean, between us and these galaxies, yeah, I'll give them it's 13.7 billion years, the farthest ones. But the rate of time is moving faster, going by faster. So the 13 billion years goes by in 6,000 years, where we are inside of our galaxy, because our galaxy time is moving slower than the time for the photons, for the light traveling between the distant galaxy and us. Time is going by faster. So that 13 billion years go by in the space of 6,000 years, which I did the math one time and it worked out pretty interesting, pretty good. I forget what it was. But anyways, it's interesting that they're not as excited as what they used to be, I guess. Expansion factor is 10 to the 12th. Um, I believe it's quite a bit, but it's the expansion of distance where there's no matter, not that the universe is expanding. Well, oh yeah, I mean, it's crazy if you want to believe in the Big Bang because it's like crazy expansion speeds. It's really crazy. Okay. Would longer spirals indicate an older galaxy? Well, they're really surprised that the spiral galaxies exist today after 13 some billion years, but of course, not time is slowed down inside the galaxy. But with longer spirals, um, actually, what they believe that it should all be blurred by now, that there should be no spiral arms, that that the older galaxies are supposed to be all blurred and not have spiral. They believe the spiral galaxies are younger galaxies and the blurred ones are the older ones. That's what they believe. They lived in New Zealand for years. Would have been great to meet with them, yeah. Nothing to keep it from expanding. Yeah, there's no matter to keep distance from being expanded. Not that it's expanding, but that it's expanded where there's no matter. Anyways, I'm trying to close down the live stream, but I keep getting more viewers, so I don't know. Maybe I should go into genetics. But that would be one of the things. Um, See, I guess I could talk. I don't know. I'll see if I lose people when I go into genetics, or the breaking up of the continents. Cool. Thank you. Okay. You have to stay. The other question. The other question. Where's the other question? Okay, Brother Tim. Sandy. See. Um. What was the other question? I don't. Did I lose it? Oh, Jamie Russell. Jamie Russell, Middle Earth. There you go. Oh, Oh, that Jensen has some errors. Uh, yeah, I believe Dr. Jensen has errors, but only in reference to the assignment of haplogroups, because he's doing some good work. Dr. Jensen is doing some good work as in calculating the genetic distance and the age of the genomes, or the mutation rates of the genomes of the both the mitochondrial and the Y chromosome. And the breaking continents is fascinating. There we go. I believe it's fascinating too. Oh, about plasma. Let me see. Okay. What was the yeah, I didn't see the website yet, so I can't really say, because I'd have to I can't really copy and paste it very well here, the link, unless maybe if you came inside and posted it in the comments inside the chat, I might be able to copy and paste it, but that might not be possible. Okay, so we got okay. There's a private, yeah, the private chat. Okay, well, I guess I could maybe explain a bit. No worries, happy to catch you. Okay. I like talking about genetics, so there's beating a dead horse, but I like talking about genetics. It was a random question. Do you think the water in Genesis could be the plasma form of H2O? Um, I'm familiar with that teaching that everything came from water. Everything was made out of water. I mean, basically, yes, everything is from hydrogen and oxygen, and you get the heavier elements from hydrogen. Anyway, um, it's a possibility, but I believe the Earth was covered with water, and the Earth came up out of water, and of course, we are made of water. We consist of water, and of course, carbon and all the other elements. The universe is 90% plasma. The matter in the universe is 90% plasma. Could be, yeah. Well, I mean, there is a lot of plasma in the universe between galaxies and stuff too. Um, but well, plasma is like charged particles. I don't know if it's could be seen as water, but we have to be open, and open to different ideas, of course. Yeah, yeah. There is a lot of plasma in space. We're surrounded by plasma, and it's basically what protects us too. And I mean, or the magnetic field basically protects us of this. The solar system's magnetic field. Um, Anyway, let me see what we got here. Whoops. Uh, yeah, well, I can explain a little bit about the difference between Dr. Jensen's beliefs about the haplogroups, because I believe that he says the T, which is found in large amounts here in the Horn of Africa, the T haplogroup, he believes that's the original Judaic or descendants of Judah and or I guess Israel or somebody or Abraham. So that would be all the, I guess, all the Arabs and Jews and Hebrews. The other place they're found is in India, somewhere where it's right here, India. Is the other place they're found in significant numbers, but the original place, from what I believe, the T is the Greek sea people. So the sons of Javan are Elisha, Kittim, Tarshish, and Dodanim, but they're all in the Mediterranean, Tarshish being in Spain, which is the reason why Judaic populations in Portugal have so much tea, is because of the Tarshish being the T. Here's the T again, yeah. See, so T is over here, the Tarshish population being in Portugal. And it's interesting, this might be an unrelated fact, but I think the mitochondrial DNA maternal lineages are of Portuguese are mostly V instead of H, like in more to the north of Europe. But it's just a different lineage of mitochondrial DNA. But the T is here in high concentrations, and the Jewish people that have the most T are Bragança population in Portugal. Or is it Bragança or is it the other one? Or one of the populations, the Jewish populations, have significant amount of T, but everywhere else they don't have any. They don't have as nearly as much T, and some in many cases not any T. They only have any amount of T because of this Portuguese Jewish population, probably. But the T is also interesting in that it's probably representative of the Phoenicians too, that existed here in the times of Solomon when they were at peace with the world, basically, but also Phoenicia, which probably had high concentrations of T, being that the populations were basically Mediterranean anyways. But I never thought about the reason there is any T at all in Jewish populations is probably because of this Tarshish population here, descendants of Javan, which is in the Portuguese population as well. But that's the first time I thought about that. But anyways, but that's what he believes. But the T is more, if you look down here, you see over here is, you got the LT. So you have the LT, the KLT is more of this Eurasian spectrum. So the Eurasians are European R, R1A, R1B, and there's an R2 in India. So the R1A is probably Ashkenaz. R1B is Togarma, known to have been in southern Europe. And the R2 would be, Ripfath. Did I say Togarma? R2 would be Togarma. R1B would be Ripfath, known to have been in southern Europe. Also in Europe, in places, is Q, which some people think that they're closely related or the same lineage, but they're not actually the same lineage. They're just two different brothers. This is Gomer, R is Gomer, Q is Madai of the Medes, because everywhere that Q went, whether in Europe or to the Americas, he has accompanying him a Semitic mitochondrial lineage, because it's known from historical records that Madai asked to marry one of Shem's daughters. So the Eurasians had many sons, 7 of them, but they probably didn't have as many daughters. So Madai asked to marry one of Shem's son, and sure enough, a Semitic A, X, and W accompanies Madai wherever he goes. It's the same lineage. It goes to America, and it goes to Europe as well. But Madai was in Europe, and Madai also, the Q also goes to America as well. But they are Eurasian. It's Gomer, Madai, they're part of the same litter. No, I'm not. They were born at close to the same time, so that's why they're both P. And the M and the S is actually a part of K. Believe it or not, the M and the S and the K are the same lineage. And the L and the T were born at the same timeline, but of course they're two different people. The L would be the Thracians from Tiraz. The T is Javan, the father of the Mediterranean populations, or the Mediterranean Sea people. Both of these are Greek. They consist of the Greeks. So when Alexander the Great went to India, he took with him the L, went to India. There's huge L populations in India. The N and the O are Meshach and Magog. Meshach went north all the way up into Siberia and is up in Siberia totally separate from Magog, who eventually moved into the east, displacing the descendants of Sinim. We know that China is called Sinim in the Bible because of probably its origin as the descendants of a Canaanite tribe called Sinim. And that's why Sinai is Sinai too, because Sinim, from there probably went to China. At least some of the descendants went all the way to China. But eventually, the DY chromosome, which is a Canaanite tribe, Sinim, was displaced by the O population. And in Japan, there's a known history of the O population pushing the D population, which is the Sinites, the Sinim population, up into northern Japan. That's a known human history. And of course, the land of Sinim is known as being the end of the earth. So Japan is as far as it can get to the end of the earth. So that would be the Canaanite tribe, which is Hamitic, of course. That's why it's a DY chromosome, which is because the D is more associated with the E, which is E1, E2, and E3. But the B and A, which is where the C comes from, is a separate population known as the Cushites. So the son of Cush, the C population, is the son of Cush. That's why it's connected to the A and B, and sometimes not the D and the E, because the D is more associated or aligned up with the E2, because there's E1, E2, and E3. E3 being Mitzrayim, which is the largest population. So when we see E3, there's the largest population. There's a lot of sons. Mitzrayim had a lot more sons than Put and Cush. apparently, or they flourished more for some reason. But he has more sons. The only one that had a lot of sons was Canaan, but since Canaan was in the area of the Semitic population, which he wasn't supposed to be, there's not the only populations left of Canaan, which is E2, would be in Africa and or the Sinim population, the Canaanite tribe of Sinim that went to China, that's the reason why China is called Sinim, the land of Sinim, which seems to make a lot of sense. So, yeah. So then that's why you have all these E3s. These are all E3s. All these E3s then would be descendants of Mitzrayim, which they went everywhere. They went this way, that way. They went this way, that way. And there's even Sinim populations in way up in Anatolia and everything like that as well. I mean E3 populations, which what did I say? Sinim. There's E3 populations all the way up in Anatolia. Then there's the E2 right here. E2. This would be the remnants of Canaan, other than D. With D here being of course the Andamanese and the Tibetans. There's D1, D3, Tibeto-Burman. The Burmans and Tibetans with a D. This is the land of Sinim. This is China. The original population, Sino-Tibetan. Reason why China has this name of Sino is because of this connection here of the D haplogroup of the Canaanite tribe called Sinim. That's why it's called Sino to begin with. But of course, the D goes up here at the Paleo-Siberian. This is the area of the Denisovan Cave, not too far anyways, which explains why the Denisovans are partially Hamitic and partially Eurasian, because of both the C, which is the descendants of Nimrod, and the D, descendants of Canaan, or the Canaanite tribe Sinim. Of course, they went all the way over here. Jomans, the D2 is over here, Jomans, and the D2 Ainu Japanese. The Ainu Japanese were forced out of this area. The old population came in here and forced out the Ainu Japanese, the Jomans, up into the north, where they live, where they are to this day, in larger numbers. The D2 population, which is, of course, Hamitic. This is a Hamitic population, Hamitic male paternal Y chromosome descendancy. So the Magog eventually moved into this area went east, and basically, displaced whoever was there, probably, pretty much, or just filled the area at any rate. But Meshach went north and pretty much stayed north. So Meshach is all the way from Finland, all the way, the end population, all the way in Siberia, all the way to the end. And of course, the Q is Madai, which is also in Europe, believe it or not. I was surprised to see Q in Europe. Right here. This area here is the area where Madai was in Europe, right? In this area here. And this is the same area where the X and the W maternal Semitic lineage accompanies the Q, Madai in Europe. But over in America, It's the same maternal lineage as the X and the W, but it's an A mitochondrial haplogroup, or an A maternal haplogroup that accompanies Q all the way to America. So it's very interesting. So then the Semitic populations would be the F, G, H, and I and J. The F shows here, oops, it, it has it grouped here is the way they do the genetics. They have to connect the A, B, C, D, and E to the F, G, H, I, and J, and they have to connect the F, G, H, I, and J to the K, element O, P, Q, R, S, and T. But the reality is that there are three brothers. This largest one, the Bible says that God would enlarge Japheth, the largest one being the sons of Japheth, which are all the ones I mentioned. There's Javan, Tiraz, Meshech, Magog, Tubal, which is also K. In Italy, there's still 8% of the original population of Tubal is still in Italy. Central Italy, 8% of the population is K, which includes this K, M, and S is all the same area where the M and the S is. There's the K, and it's basically the same lineage. So that's Tubal. Then there's Madai and Gomer. That's 7 sons of Japheth. Right there in the haplogroups, right in the basic haplogroups. Up here, if I can find it, up here is the K. What do you know? K, M, and ES, all in the same area here. But these lineages are separate. The M and the S are separate, but they basically originate at the same place, which is the K. They're just separated very, very long ago, a long time ago. So, but they're basically the same K population. And of course, K is Eurasian, M and S is Eurasian, C is Hamitic. So you got the C4 in Australian Aborigines or Aboriginals, and there's also the K, which is Eurasian, which is what the Denisovans are. And apparently there's even more similarity to Denisovans, not only the Papua New Guineans or the K population, but also the Negrito populations in the Philippines also have a lot of Denisovan DNA. So, and of course, it's a mix of Eurasian O as well as the Eurasian K, the Eurasian O, as well as the Hamitic C, autosomal DNA in the area. So the C's would be the descendants of Nimrod. That's why Polynesians look like the Olmecs, because they have the same ancestor C, Nimrod, who is a descendant of Cush. And that explains why they don't look exactly African. The Olmecs don't look exactly African, but they do look Polynesian because they have the same ancestor, Nimrod. Then we have R1b, Chadic. The R1b is in Africa, but of course the R1b came from Mediterranean area. Actually, one of the King Tut is an R1b I think, which was a surprise to the Egyptian authorities, so much so they didn't publish the results, and somebody else had to publish the results because they didn't want people to know that King Tut wasn't didn't have African DNA. He had Southern European DNA, R1b. But anyways, so yeah, getting back to this, E2 would be Canaanite tribe. Then the E1s is probably what Put would be the descendants of Put, or the original Phoenicians that Josephus talks about in the northern Africa would be the what he called the Phoenicians, but the descendants of Put would be E1A or E1. So E1 is Put, E2 is Canaan, E3 is all Mitzrayim because he's the one that had the most sons, and of course he's referred to as Egypt. So even though it says Cushitic here, this E3 is the same population as the Berbers over here and the Egyptians over here. So all these E3 lineages are all probably descendant of Mitzrayim, who had many, many, many sons that went in all different directions, went all over the place. They went everywhere, which is very interesting too. And then, of course, you have the actual Cushites, other than Nimrod, who was a C. Other than Nimrod being the C, the other Cushites would be the A and the B. So the B populations, the A populations, these A populations here, these would be the original Cushites that, of course, migrated this way. And these, of course, this is majority population. It doesn't mean that A and B are not in these populations. The A and B are all over, but just that they're in greater percentages in these areas here. And down here, the Khoisan are descendants of Cush. Supposedly the oldest. Oh, we have some E2 down here too. So E2, these probably original Canaanites. Unless somebody can show me something different, about that. But somehow Dr. Jensen thinks that Eurasians are Semitic. That includes Siberians. It includes Chinese, Korean. It includes European R1A, R1B. He thinks those are all Semitic. Dr. Jensen thinks those are Semitic. And it also includes the T and the L. The T and the L, he believes, are Semitic. He thinks the T is the original Judaic or Israelite population. But the reality is that of course, we have the population of Tarshish here, Dodanim, Kittim, and the descendants of Javan are basically Greek seagoing people. And the Greeks had trade with the Horn of Africa down here. The Greeks had trade with the Horn of Africa, and to this day, there's Greek populations in the Horn of Africa from the Greek trade, and vice versa. There's African populations in Greece as well from the trade between Greece and the Horn of Africa with the original population of T. And the L population was brought to India because Alexander the Great liked to ride elephants, so he brought the mainland Greeks to India, and the T is also here as well. So probably he brought the T and the L when Alexander the Great went to India and didn't want to go back over here. He liked riding elephants or something like that or something. Anyway. But anyways, that's the way it works. But to me, it's hard. You can't see this. It says Middle Eastern Semitic, J1. I mean, how are you going to displace the Arabic populations and the Judaic population from the Middle East and say that they're now one of these Eurasians up here? So Dr. Jensen effectively switched the Eurasian populations with the Semitic population, but he has some I forget what he has exactly, but somehow I don't know. But he thinks that all these Eurasians, he thinks those are all Semitic, and somehow these are Japheth. Somehow the descendants of Japheth, the Turkish, he says the Turkish invaded the area and the Turkish, moved it. He thinks that J1, J2 was Turkish or the Turks, when in fact the Turkmens here are descendants of Madai. The original area of Madai is right here. So the Q right there, descendants of Madai, are right in the area where they were originally. Of course, Elam, this is the area of Elam right here. This area here, right here, is Elam, where the Elamites were. And they have this known connection of Elamo-Dravidian, and here you go. Here you have the Dravidian, have the H paternal haplogroup, which is Semitic, which is a Semitic haplogroup. The H, wow, this is getting hard here. The H is a Semitic population, as well as the G. The G is Assyrian, the Assyrians, or unless somebody can prove that the G was Arameans or something, which is also Semitic. But for the time being, this is the Assyrians. This is the original area of the Assyrians, and you have the Assyrian population here. This is the original area of the Medes, and you have the Mede population here. This is the area of Elam, and you have the Elamites here, the H, the Dravidian H. Elam, and they're known to have migrated. If you ask the Dravidians where they came from, they say they were Arabs, came from the Middle East. Quote unquote Arabs, but of course they're actually Elamites with a Semitic H haplogroup. But somehow Dr. Jensen believes that the northern nations became the Middle East, and the Middle East became the northern nations, which is totally absurd. But anyways, you have to. That's why I had to build the haplogroup family trees from the bottom up, and then follow the movements. We had to follow the movements, and it's just a process of elimination as you go along, because you have this movement of the Medes up here in Europe, and there they are, right there in Europe. There they are. That's the area of the Medes in Europe, known from history. So you can't say that they're Gomer. No, Gomer is Ashkenaz, Ripfath, and Togarmah. R1A being Ashkenaz because the Ashkenazi Jews actually took on the name Ashkenaz for being in the area of the Ashkenaz, or the land of Ashkenaz, or the known people. And Ripfath is known to have gone into Southern Europe somehow. So you got, you have to line it all up like that, as from known historical history. And the thing, of course, that got me started was the king of Shinar. This is the land of Shinar right here. The king of Shinar, which is later became the Assyrians, or the Babylonians, Assyrians. But the interesting thing is, if you read the Bible connects Nimrod with Assyria. He talks about Israel being freed from the grip of Nimrod and Assyria. The Bible connects Nimrod with Assyria. Nimrod being a Hamitic descendant of Cush, and Assyrians being a Semitic descendants of Asher. That's why they're Assyrians, because they're descendants of Asher. So, what do we have in Babylonia? What are the Sumerians? If you look carefully at the Sumerian, statues and everything, with with them holding lions and stuff like that, and on chariots and stuff like that. If you look carefully at the rulers, because they're rulers being depicted. Those rulers, those Sumerian rulers, are the ruling class of Assyria, which that ruling class is the descendants of Nimrod. Because if you look closely, you'll see on the back of their necks, their hair, bunched up in the back of their neck, the back of their head and neck. You'll see the hair bunched up, either bunched up or tied back or something, and with the curly beards. Those images are the descendants of Nimrod. They're different people, but they're descendants. They're the ruling class of the Assyrians, which history knows as Sumerians. Those Sumerians are Assyrians governed by the descendants of Cush, which they later went into Europe as well. So that the CY chromosome is found in Europe. The Cushite C descendants of Nimrod are found in Europe. That's why they say the first Europeans were darker. The original Europeans were darker. Well, now you know the rest of the story. Okay, because there is a CY chromosome all the way in Europe. But what got me started was this Hamitic CY chromosome here, which is also here. It's also in this area too, but they moved east. The descendants of Nimrod moved east as well as going into Europe, but I guess either they came back or whatever. But most of the surviving descendants are in this area here, known as Mongolic. They're Mongolic descendants of Cush, and of course they go all the way to the Americas, and it's the reason why the Olmec statues look Polynesian. So that's that. But that's what got me started, was this C paternal haplogroup. I'm thinking, well, who could that C? Who could this Hamite be? And then it dawned on me, it can't be anybody other than Cush. So I'm thinking, well, who's Cush's father? Cush's father, not Cush's father. Who's Nimrod's father? Nimrod's father is Cush. I'm getting names all mixed up now, I guess. But anyway. So then it dawned on me, all these C descendants are descendants of Nimrod, the house of Nimrod, which is reason why they call it a house of Nimrod is because it's had large population, many descendants. The same thing as the house of Judah is many descendants. This J2M172 right here, that is the largest J2 population is M172. Those are probably direct descendants of David, King David, and Solomon, the house of David, right there. J2M172, largest J2 population. And with J2 in general being Judah, the other descendants of Judah, perhaps not descended from David, descended from somebody else. Or, But Judah, you know, Judeans are called Judeans because of their descent from Judah. So, so that's the thing. You just gotta. It's a process of elimination. Meshach went north. We know Meshach went north. So there you have the N right there. And O went north too, but for one reason or another, either went east and moved east and displaced the original Sinim tribe that was in China for the namesake, the Sino namesake, of Sinim that the Bible uses. The Bible calls China Sinim. The Bible says Jews will come from as far as Sinim. And of course, if you follow the Silk Road here, the Uyghurs, the largest Y chromosome percentage of the Uyghur population is J2 Judaic in the land of Sinim, in China, in China. And of course, there's other populations, not just the Uyghur population. There's other Judaic populations as well. Even in India, even here in India, in India, there's still there's places with Judaic populations, from what I understand. So it's really it's a lot of work. You have to change some things here and there, but it's pretty good. The only thing I don't really have down straight is the F. You see these Middle Eastern Semitic, the F. There's two F lineages. There's actually three. There's F, which is the whole group. There's F2 and F3, and they're totally separate from each other. So I have assigned F2 as being what, Lydians or something, or Arameans, or vice versa, and the other F population as the Lydians, which were the youngest sons, according to the the reverse of the out of Africa. The IJ comes first, then the G, no, then the H comes. Well, you have it down here probably. The IJ comes first according to the genetic SNPs, then the H, then the G, and then the F. But of course, I have it the exact opposite of the out of Africa, because Ham is the youngest son of Noah, so he can't possibly be the root of the tree. So the root has to be with the Eurasians, which is Japheth. Japheth is the oldest son. Shem is the second born son, and Ham is the youngest one, as stated in the Bible. So what we have here is that this IJ is connected to his uncle because he still retains a marker with his uncle that his other brothers lost, because I have it exactly backwards, exactly the opposite of the out of Africa, because they have it exactly backwards. I have it exactly right. So the oldest son, Japheth, has a marker that is shared by Arphaxad or Arpachshad, who has the IJ descendants, which is Hebrews, Israelites, Jews, and Arabs. So the IJ descendants, God said he would make many nations from Abraham. Those are the descendants of Arpachshad. But since he's the oldest son, he can share a SNP or a marker with his uncle, Japheth, that is then lost to his other brothers who were born later, which is Elam was the next one in line, then Asher, then Lud, then Aram and Lud. Of course, the Arameans and Lud, either that, the only thing I don't have really straight is whether or not the Arameans might be a G, might be a G2. Maybe the Syrians are G1 or something. Maybe Lud is the F, or something to that effect, which I don't have straight. That's the only thing I don't have straight as in my mind as to which is which in the haplogroup. But of course, I'm wasn't raised in the Middle East, so I'm not familiar with any of the actual history or anything of the Arameans or the Lydians or this or that or the other thing. Which somebody could help me with that to find out which is which, whether or not G is all Assyrian, which could be the case, and maybe the Arameans are F2, and maybe the Lydians are F3, or something like that. Because there is such a thing, besides F being this whole group. But the Hamitic population is kind of clear cut though, as well. So A, B, and C are descendants of Cush. D is a branch off from E2, which is Canaan. E3 being Mitzrayim, E1 being Put. So E1 is Put, E2 is Canaan, E3 is Mitzrayim. And the B and the A and the C are descendants of Cush, which works out very well. Because the same way that Arpachshad is the eldest son of Shem, sharing a marker with his uncle Japheth, same thing is true with Nimrod being the oldest son of Cush, who was the oldest son of Ham, which shared a marker with the rest of the population go on this way, which is later lost to the younger descendants of Ham, who lost the marker that Nimrod shared with his other two uncles, or great uncles, actually. So, but that's possible if he was the oldest. Only possible if Nimrod was the oldest son of Cush, who is the oldest son of Ham. As far as I can figure out, which is probably the case, because Nimrod, of course, became the king of the world. He was the oldest son. Everybody followed what the oldest son did, until the breakup of the continents. Then people were isolated into their family groups, began speaking their own languages, and they spread out. Then they spread out from there. And Nimrod was left king of Shinar by himself in the land of Shinar, Mesopotamia, which stories say he was later killed by Jacob's brother Esau, who was also a hunter, maybe had some kind of rivalry with or hatred of Nimrod, supposedly killed Nimrod, ran back to his father's house, Jacob, and lost his birthright because he was hungry, starving, about ready to die. No, that's just making up a story there, but I guess it's a possibility. But yeah, because Nimrod could have had the age, being only the grandson of Noah, or great grandson of Noah. Nimrod could no, yeah, he could have had lived long too, because it was still before the breakup of the continents. They were still living long, so it's still a possibility that Esau could have known or lived at the time of Nimrod. But that's another rabbit hole. And as the stories go and stuff, Okay, so and the Persians were always a mix. The Medes and the Persians, they're already a mix of people, but the Q remains part of the population. Persians would be, I guess, anybody else who's around, as well. Let me see. Here we go. Let me go back here. I don't know what that's doing there. Okay. George Bond. There we go. Sorry to have to go. Catch you later. nice, nice of you to come visit, George. But no problem there. God bless you. Stay watchful. Okay, bye, George. Okay, thanks for all you do. Okay. And I do enjoy what I do, which is maybe not a whole lot, but see, a lot of Indian Jews, yeah. Yeah, I knew about that. In fact, I know that's why I mentioned it. I know who's a part of that. Jonathan Kahn is a part of that. So that's or at least he was a part. I'm not saying he's a part of the Aliyah or anything, but he was involved with that. Oh, yep, yep. The J2 M172 is the largest J2 population, probably direct descendants of King David and Solomon. Okay, so here we go. On that channel. Okay. Schwab Soros and Gays are past their years. Let's see, Schwab. Yeah, I don't know. I don't know what's up with that Schwab guy. That Santa Claus Grinch. Uh, oh, he's European. Yeah, they. I mean, even the secular scientists recognize Eurasians as being a single group, of people which are not Semitic, not known to be Semitic. Oh boy, Alberto Company. OB founded the Oh Boy Alberto Company. Okay, OB. Well, now I have to watch it from the beginning. Put it on high speed. You can always watch. You can always watch something on high speed, which is what I do. I put it on time and a half or time and three quarters, and save time that way, and you listen to the whole thing, or listen to more that way. I do, anyways. That's how I do it. Watch videos, random quick. Okay, all right. I guess that's about it. Unless I want to get into the breaking up of the continents, which I already did a little bit. But I guess that's good enough for now. I got 2 hours going, so I guess that's good enough for right now. So God bless everybody. Thanks for your participation, and let me see. Guess I don't have anything else to mention. I guess. So I'll see everybody soon, hopefully. today I have the day off today, so I figured I might as well just take time to make a video. Oh, by the way, Mr. James Tour put out another video. It seems like an older video, but it's still a good video. It's pretty good. Somebody might want to watch that James Tour video. So yeah, thanks a lot. God bless everybody. Take care. Stay close to your Savior, your Creator, because He's the only one who can help us. God bless.